Good morning, dragons. I hope you're ready to start in on our interactive notebook this morning. We're going to work on page 68, which is an extension of our ratio studies. So I've made you a form. If you're unable to print out your form, feel free to draw the notes by hand. You could probably have fun with this one because there's actually illustrations. It'd be like an art/math project integrated for your amusement. I'm going to trim this out, put it on page 68 for us. If you don't have any colored utensils, that's okay. A lot of people have told me they don't have all the supplies I have, and I don't really expect you to. I took home everything from GSA from my desk about a week ago because they let us back in the building. So I do have my stuff. I might still have to trim that down more. It's going to be a tight fit. Okay, so comparing ratios was actually one of the sections back in the day that came directly after Introduction to Ratios. And comparing ratios is when we started to discuss different ways to write it, plus different ways in which to compare it. So a ratio fundamentally boils down to a part-to-part or a part-to-whole. A part-to-part is a fraction. A part-to-whole is a fraction. This one is a fraction. There are three ways to write it. You're either going to write it in colon notation, fractional form, or with words. Example 1. Analyze each statement to determine whether a part-to-part or a part-to-whole relationship exists. Back when we worked on ratios, you did this exact type of assignment in your skills practice packet. There are 9 girls for every 2 boys in the class. 9 girls for every 2 boys in the art class. Is that part-to-part or part-to-whole? If you said part-to-part, you're correct. Three out of every 5 students in art class will help paint the mural in the library. Is that part-to-part or part-to-whole? Part-to-whole. Good job. There are 3 blueberry muffins to every bran muffin in a variety pack. It is implied here that there is only 1 bran muffin. There are 3 blueberry muffins to every 1 bran muffin. Which relationship is that? Part to part. Good job. There are 9 calories of fat in every gram of fat. That one is unusual. It is a part-to-part. Of the 30 students in chorus, 14 of them play the piano. Of the students, that implies of all the students, 14 of them play the piano. If you said part to whole, You got it correct. The students planted 22 yellow daffodils and 10 white daffodils. There are different types of daffodils. I do want to point that out. So your answer is part to part. All right, recapping. We've got part to part, part to whole, part to part, part to part, part to whole, part to part. Excellent work. Let's do example 2. Of the 40 boys surveyed, 24 like to play soccer. Of the 65 girls surveyed, 26 like to play soccer. Which is greater, the ratio of boys who like to play soccer to the total number of boys surveyed, or the ratio of girls who like to play soccer to the total number of girls surveyed? Feel free to pause the video and find a way in which to compare these two ratios, because you've got different numbers all over the place. I do recommend scaling up or scaling down to make your comparison easier to read and easier to understand. So feel free to pause now. So as I was looking at it, I was thinking I'd like to do 2 different ratios here. I'm going to put the work in here. So if I have the boys, and the boys are 24 to 40, 24 who like it to 40 total, I'm going to put S for soccer. 24 who play soccer to 40 total. And then over here with the girls, I've got 26 who like to play soccer to 6. Their total is much greater, to 65 total. Total surveyed. I feel like I want to scale it down to some type of like denominator, because if I have a like denominator, then I could just compare the numerators. I do feel like there's a possibility to scale down all the way to 5. Did anybody have a different idea? Did you scale to something else? If I divide by 8, top and bottom here, just testing it, I haven't actually done it. I were to divide by 8, I could get down to maybe 5 total to 3 soccer. So I'm looking at 3/5. Alright. That's pretty reduced. So that's not bad. This one isn't as friendly because 5 can't go into 26. So I'm wondering what I could do with that. So some factors of 26. We could do 2, but 2 is not going to be friendly with that. Maybe 3, not so friendly. 4, 5, 6, 7, 13. 65 is not divisible by 13. See, not the prettiest fraction. What do you think? What should I scale down to? Or would it have been easier to scale up? And 65 divided by what would get me 5? If I want to go that route. $13 will work. 13 is a factor. Let's divide by 13 top and bottom. So 26 divided by 13 is 2 students, 2 girls specifically, who play soccer. 65 divided by 13 would get me 5 total. So I was able to scale it down using a common factor between 26 and 65. Now I need to compare 3/5 to 2/5. So which ratio is greater? The boys tend to prefer soccer versus the girls preferring soccer. So in this one, the boys win. Alright, another interactive notebook page for the books. You've done an excellent job. I'm going to have to trim mine down just a skosh more before I glue it in. But it's going to live right there. Just like that. So again, if you don't have a printer, go ahead and write it by hand. Take your time, make it look nice. We will be submitting interactive notebook pages during quarter 4 for an actual grade in PowerSchool. Thank you, Dragons.